Welcome back. This is the second day of Code Dive 2017. Let me kickstart the day by introducing the first speaker of the day, and the first speaker is Douglas Crockford. Now, Douglas is a very interesting person on many levels. You may not know that he turned his back on a promising career in television because, well, he discovered computers at some point. So he has worked in learning systems, small business systems, office automation, games, interactive music, multimedia, location-based entertainment, social system, and of course, programming languages. He is the inventor of Tilton, and Tilton is the ugliest programming language that was not specifically designed to be an ugly programming language. He is best known for having discovered something that happened at the beginning of the 21st century. I'm going to tell you about the discovery in a bit. He also discovered JSON, the world's most loved data interchange format, and he's currently working on making the web a secure and reliable software delivery platform. So as you can see and guess, he has his work cut out for him. Now, two key facts about Douglas are that first, he was born in, check this, he was born in Frostbite Falls in Minnesota. So that place is called again Frostbite Falls. But he left the place when he was only 6 months old because it was too damn cold. And the second thing, and it's about the discovery, is that Douglas really is known for having made the first important discovery of the 21st century, and his discovery was that JavaScript has some good parts. So with this, I'd like to invite you to watch and listen and enjoy Douglas's talk, and it's called The Better Parts. Let's give a warm welcome to Douglas Crockford.
Good morning. So let's start the day with some better parts, shall we? So I'm going to start with this guy. This is Antoine de Saint-Exupéry. Please excuse my French. He was an aviator at a time when we called pilots aviators, when aviation was really dangerous. And aviation was really dangerous because the planes would crash. And in his career as an aviator, he experienced several crashes and survived almost all of them. He was once trying to set a speed record from Paris to Saigon, but his plane failed and he crashed in the Sahara Desert just outside of Cairo. And he was not prepared for desert survival, so he suffered terrible dehydration. He dehydrated so much that he stopped sweating, which is a really dangerous thing to do in a desert. And he suffered horrible hallucinations. Fortunately, he was rescued by someone who knew how to treat severe dehydration, and he survived and he recovered. Then World War II starts, he's exiled to America, where he becomes a writer, and it turns out he's a really good writer. He's best remembered for having written a children's book called The Little Prince. It's about an aviator who is stranded in the desert, who is visited by a strange little boy who lives on an asteroid and is suicidal. Like most of the great children's books, it's not really a children's book, but it's really, really good. He wrote other books, more grown-up kinds of books, and one of them contained one of the best sentences ever written. He said, "It seems that perfection is attained not when there is nothing more to add, but when there is nothing more to take away." It's just a brilliant sentence. I've seen it copied and quoted all over the place. It's used in talking about design and architecture, anything that combines creativity and discipline. He was talking about the design of airplanes, but it seems to talk about everything. And I think it's particularly important in thinking about computer programming, because we have a special relationship with perfection. Our trade requires more perfection than anything else. Our programs have to be perfect or they fail. So he gives us some insight into how perfection is obtained. It's not obtained by adding things, it's attained by subtracting things, by removing things, by simplifying things. And I think we can apply that to the design of programming languages as well, which leads to the principle of the good parts. The good parts idea is that if a feature is sometimes useful and sometimes dangerous, and if there is a better option, then always use the better option. It surprises me that this is still considered controversial. It seems to me that this is obviously true. But there are a lot of people who complain, you can't force me to use the better option. It's like, why are we arguing about this? And I think it's due to a fundamental misunderstanding of what it is that we're supposed to do. We are not paid to use every feature of the language. At the end of the project, there isn't a manager with a clipboard who says, did you use plus plus? Did you use a with statement? Did you use comma as an operator? Did you leave out any semicolons? Excellent. No, nobody cares about that. We are paid to write programs that work well and are free of error. That's what we're supposed to be doing. Now, free of error, when did that become part of the deal? Well, it turns out it has always been part of the deal. It's the most important part of the deal, but we do it so rarely that it's easy to forget that that's the really important part. So I recommend to everybody, learn as many programming languages as you can, because a good programming language will teach you. It'll change the way you think about things, and you can use that improved model of thinking in other languages as well. So, a good language will teach you. And the language which has taught me the most in my career has been JavaScript, which really surprised me, because the first time I saw JavaScript, I thought it was the stupidest thing I'd ever seen. And so I made every mistake that you can make in JavaScript, starting with the first one, the worst one. I didn't bother to learn the language before I started writing in it, because I thought I understood what it did, and I also thought that there was so much wrong with it, I didn't want to damage my brain by being aware of how it worked. And that turned out to be a really foolish thing to do. And JavaScript punished me severely for that, and it continued to punish me until finally I decided to try to learn the language. And once I learned the language, suddenly I had this epiphany that this language was not at all what I thought. And as I started learning, it made me smarter about how to be a programmer. One thing that concerned me about JavaScript, though, is that it contains a lot of design errors, because the thing was designed and implemented in 10 days. And it turns out you can make a lot of mistakes in 10 days. And those mistakes are still preserved in the standard of the language. And so you need to be aware of that and work around it. So I developed a program called JSLint, which I wrote in JavaScript, which reads my JavaScript programs and tells me when I'm using the features of JavaScript, which are more likely to create errors. And JavaScript is also instructive about programming style. When I started it, I had no intention of trying to enforce a programming style, because my ideas of programming style at the time were completely wrong. Over the years, JSLint taught me to be much smarter about that there are certain ways of writing programs which are more likely to cause errors or more likely to hide errors. And so if you can avoid doing that stuff, then your programs are better, that the mistakes tend to stand out and it's easier to get things right. So I wrote my own book about my adventures with JavaScript and JSLint and what I learned on that journey, and it's called JavaScript: The Good Parts, and it's still in print, and it still sells well, which is surprising for a software book to be sold 10 years later. Most software books are obsolete at the time that they're printed. So this one is still relevant, because what I recognize as being good parts in JavaScript turns out still are good parts in JavaScript. Even so, there are lots of arguments against using the good parts. And I think it'd be a good time to review some of those arguments. The first one is, it's just a matter of opinion. That, you say something's good, I say something's good, we don't have to agree. That all opinions are equally valid. And that turns out not to be true. So I am the maintainer of JSLint. So I get reports from people all over the world, and it doesn't happen very often, but occasionally someone will write to me and say, we just had this terrible bug and we spent 2 weeks chasing it down. It was some weird corner case in JavaScript that nobody recognized. And we lost a lot of time and a lot of money on this. And could you please put a warning into JSLint so that this doesn't happen again? So I'll look at their report, and if it makes sense, I'll incorporate it into JSLint. So if you're using JSLint, it means that that will never happen to you. That is not an opinion, that is a fact. Every feature is an essential tool, and I need to have access to every possible tool in order to do my work. And it turns out that's not true. That there's some tools that just don't work very well, and there's a small set of tools which work really well, and those are the ones you should be using. So if you can produce better programs by using a subset of the tools, then the tools that are unnecessary are not essential. But a tool is sometimes useful. And this sounds like a good argument. I should be able to use something if it's sometimes useful. But it turns out this isn't actually an argument. Everything is sometimes useful. We are really good at finding uses of things. And there is nothing so damaged, so vile, so toxic, so disgusting that we cannot find a use for it. So everything has the property that it is sometimes useful. So if your only argument for including a feature is that it's sometimes useful, you don't even have an argument. I have a right to use every feature. Okay, I have a right. That sounds really important and good. But we've now changed the conversation. We're no longer talking about what is the best way to write programs. We're now talking about our rights. And it turns out this argument bottoms out at, do you have the right to make crap? Yes, I have the right. Yeah, I have the right. Who cares? It's not important that you have the right to write crap. What's much more important is you have a responsibility to write programs that work well and are free of error. I need the freedom to express myself. I am an artist, I am a poet, and I express my poetry by leaving out the semicolons. I need to reduce my keystrokes. So we imagine, that we spend most of our time typing. What I do today, I was typing, I typed a program, it's go ta 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 ta. That's how I spend my time. But that's not actually how we spend our time. We spend most of our time staring into the screen saying, my God, what have I done? That's where the time is going. But we're obsessed with trying to figure out how to cut out as many keys as we can. If you could multiply the number of keys by 10 and cut your errors in half, that would be a good trade-off. Removing keystrokes is a waste of time. It is an insult to suggest that I would make a mistake with a dangerous feature. Obviously, someone who's incompetent or less skilled, less brilliant than I am could make a mistake doing that kind of things. But it's an insult to me personally to say that's silly. And there's a good reason those features in the language. And having participated in the standards process, I can tell you for a certainty that is not true. There are lots of reasons that things can get into a standard, and being good is not necessarily an important one. Brendan Eich, who's the guy who designed JavaScript, brilliant guy, talks about foot guns. A foot gun is a feature of a language that you can use to shoot yourself in the foot. And he put a lot of foot guns into JavaScript. And I think he regrets that and would probably suggest that we not put any more foot guns in there. But there are folks who think, okay, watch this. I almost always miss. Watch. So the purpose of a programming language is to aid programmers in producing error-free programs. That's what it's for. So we used to think that it was not possible to write good programs in JavaScript, so there's no point in even trying. You can't do it, so just write whatever you want. And that turns out not to be true. It is not only possible to write good programs in JavaScript, it is necessary. It is so easy to go off the rails with JavaScript. There's so many invitations to write bad code that you have to bring more discipline to JavaScript than you would bring to other languages. So one of the things that's confusing about JavaScript is it has the same name as Java, and they're two different languages. And people are still confused about what's the difference between Java and JavaScript. It's similar to the confusion we have between Star Trek and Star Wars. You know, two successful science fiction franchises with spaceships and stuff, and they both have basically the same name. But the fans know that they're not the same, that they're very different. For example, in Star Trek, you've got phasers, photon torpedoes, uniforms, dam regulations. And in Star Wars, you've got lightsabers and blasters, proton torpedoes, sand, and chaos. So JavaScript is obviously the Star Wars of programming languages. And when you're working with JavaScript, you have a choice. You can go Jedi, or you can go Jar Jar. And sadly, a lot of our brothers have decided that they want to go Jar Jar. So a couple of programming patterns I've seen are the fantasy of infallibility and the futility of faultlessness. So the first one, the fantasy of infallibility, I see this mostly in young guys who think that they have these extraordinary skills and they can write just really crazy, wild, reckless code, you know, and that they can pull it off because they've got such mad skills. Then the futility of faultlessness I see more in older guys who have seen that it never works, it's never going to work, why even try? So two very different attitudes, but they both lead to the same thing, danger-driven development, where they'll take unnecessary risks in writing their code just to keep it interesting. So one of the things that makes software difficult to manage is the difficulty of scheduling. The first problem is how long will it take to write a piece of code? And asking a programmer how long that's going to take is not going to work because we are optimists. We have to be optimists in order to do this work. And as a result of that, we can't schedule worth crap. It's just a fact. Because, they ask, how long will it take to write that code? And you'll think, well, it's probably about that many keystrokes, and go da-da-da-da-da-da-da. It should be taking about that long. And because we forget about that time, right? Because we black that out. It's just the typing time, and that turns out to be a wildly wrong estimate. But then there's time B, the time it takes to make the code work well. Ideally, that should be 0, right? Time A, you write the code. B, it works, you're done. Except that turns out not to be the case, that often time B is huge. Sometimes time B is bigger than time A. Sometimes time B is infinite. That's what happens if a project is canceled after the code is finished because they never get it to work. And that happens way too often. So if you're doing anything, cutting any corners, taking any risks in time A to make time A smaller, that increases time B, you're doing it wrong. And time A is the time to try to force time B to go to 0. You should always take the time to code well. Sometimes you're doing something that's only going to have to run once, so let's just be sloppy, just get it done really fast, cheap and dirty. Except you still have to make it work. There's no point in writing the code if it's not going to work, and it's going to be easier to make it work if you code it well. In all cases, we should always code well. So there's some new parts in ES6. ES6 was approved by the ECMA General Assembly a couple of years ago, and it's now finally starting to find its way into browsers and into Node. Not everything is there yet. For example, my most favorite new feature of ES6, proper tail calls, not there yet. But this is a brilliant thing. It allows for an optimization called continuation passing style, in which you have functions which are always going forward, never practically returning. It's a brilliant way of doing things. We'll talk a little bit more about that in a minute. The ellipsis operator, which is sometimes called rest and sometimes called spread, which provides a much better way of dealing with functions with a variable number of parameters than what we got in ES5 with the arguments array. So here are two versions of the query function, which each can take any number of arguments in any position. And that's the way you write it in ES6, and that's the way you wrote it in ES5. Which one would you have to maintain? Anybody? I think it's pretty clear. I really like that one. So the dot, dot, dot means any number of things can go in that position. That's pretty nice. Modules. So in the browser, in the original implementation of JavaScript, every code unit used global variables to communicate with all of the other code units, and that turned out to be a really bad pattern. In Node, they found that to be intolerable, so they replaced it with a crappy require system, which unfortunately is blocking, and so that's not good, and it's also way too complicated. So ESX provides a module system which works asynchronously, and it can give you secure, reliable module boundaries, which is what we need. Unfortunately, the design turned out to be way more complex than I think it should have been, but there's a subset of the module syntax which is just fine, and so I'm very pleased that that's becoming available. We have let and const in the language now. Let is the new var. Let and var do essentially the same thing, except let respects block scope and var didn't. So you want to be using one of them now, and I recommend the one you use now is let, only because it doesn't confuse the Java guys so much. The Java guys got really confused about var, but with let they'll be less confused. And I think anything we can do to cause the Java community to be less confused would be a really good thing. We've got a new destructuring syntax, which I think is pretty nice. So you can see that this let statement is a shorthand for this one, where each of these variable names will be initialized with a property from this object which has the same name. And it doesn't let us do anything that we couldn't do before, but it's a nice shortcut. And there are some patterns which are nicely expressed this way. But you can go way out of hand and do stupid stuff with that as well, so recommend you not do that. Then weak map. Weak map doesn't fix a major problem in JavaScript. It sort of puts another thing there. So one of the design errors in JavaScript is that the keys of an object have to be strings. If you try to pass in an object or something, it'll try to convert it into a string before it'll use it as a key, which is a shame because there are a lot of applications which really want an object in that position. And we couldn't fix it because there are programs on the web that depend on that bad behavior. So instead of fixing it, we added another kind of object called a weak map. And with a weak map, it's like an object except that the keys can be other objects. And so there are classes of functions that can only be written using weak map that cannot be written in the language as it is. And it works really well with the garbage collector, so that if an object that's being used as a key wants to be garbage collected, it automatically gets removed from the weak map, which is really, really nice. The biggest problem with weak map is it has the worst name of any feature added to a programming language, because nobody wants to put something weak in their program, but it's really good. And then we've got megastring literals, which are literals which can be many lines long. So we'll look more at those in a moment. So this is a regular expression literal. This is a regular expression literal which matches the number literals that are available in ES6. Did anybody guess that? I'm guessing not, because these things are virtually impossible to read and understand, which really concerns me because we often use them for input validation and for security filtering. But if they're longer than an inch or two, it's really hard to know what they're actually doing. So there's a thing we can do now. I'm going to make my wrapper around the regular expression constructor. So I can pass in a string, and I'll remove all the white space and then try to turn it into a regular expression. And so that lets me write like this. So up there, that little tick is the beginning of a megastring literal, and there's a little tick there down at the bottom which closes it, so everything in between is one string. And now I can easily read the regular expression. I can see if it starts with a 0, it might be a binary or an octal or a hex or a floating point number. This is which one do you want to maintain? The top one, that one. So I think this is much, much, much better. But even so, I'm still not confident that I can accurately predict what a regular expression will do. So there's a tool available on the web called Regulex, where you can give it a regular expression, and it will give you a railroad diagram so you can see graphically what this thing is going to match. And I love that. So I will never write another regular expression without running it through Regulex. So these are some of the other new features that we have in ES6. I think these were probably bad parts. Proxies started as a well-intentioned thing that we want to have a no such method. So if you have an object and someone calls a method that it doesn't have, instead of throwing an exception, you would like the object to be able to handle it somehow. But that turned into this proxy thing, which is really complicated and kind of changes the behavior of everything. They're kind of scary. We have generators, which are sort of a good idea, except they're completely unnecessary. If you understand how JavaScript works, you know that you can write generators simply by having a function that returns a function. You've got a factory that returns a generator, and each time you call that generator, you get another value. And that's a really straightforward way of doing things in JavaScript, much better than what was actually put into ES6 because it has really weird syntax. It's very inefficient, and it's not necessary. Iterators are part of the same deal. Symbols are unnecessary because we have weak maps. The things that symbols allow you to do, weak maps do, I think, in an even better way. Reflection also work with those things. Then we got fat arrow functions, or farts, and hipsters love these, but I'm not such a fan. So the idea is that we can make a function in a much smaller way. So instead of having to type the word function, you just write a fart, and that's all you have to do. I didn't think typing function was all that hard, but so we put this in. So we've got a parameter list on one side, and we've got an expression on the other side. So when you call the function, you'll bind an argument to that parameter and return that result. That's pretty good, except for this case, this looks like it's going to construct a little object with an ID property, except this is actually going to return undefined because there was an intentional error made in the way that this was designed. And I don't know why we keep putting this crap into this language. It's got too many things where you can write something that looks completely reasonable that fails in a silent way, which is the worst way you can fail. So I don't recommend using these things. Until this gets fixed, I'm going to continue writing the word function. So the worst bad part in ES6 is obviously class. This was the most requested feature in ES6. It was mostly requested by Java guys who were having to write in JavaScript because that's where the jobs were going, but they didn't want to have to learn it. And so by putting class in there, they don't have to learn. They can just keep doing the stuff that they were doing in Java. Except it turns out that we didn't actually add classes to JavaScript. This is just syntactic sugar on top of the prototypal stuff that was always there. And so it doesn't work the way a Java programmer might think it works. And so it's sort of a trap. And also, if you keep stuck in this paradigm, you will never learn the object-oriented paradigm, where you can do things by having functions that take functions as arguments and return functions, higher order functions. That stuff is brilliant. And if you're doing this, you will never find this out. So the people writing with class will go to their graves never knowing how miserable they were. So I've been thinking about what I wrote in my book about what I consider to be good parts and what I got right and what I got wrong about that. And so in the book, I recommended not using new, using object.create instead. It's a more direct way of setting up the prototypal inheritance chain. And I managed to get object.create added to ES5 just so that I could use it. So I was surprised when I noticed that I'd stopped using object.create, because I put it in there just for me, and I don't use it. So why is that? It's because of AdSafe. So in 2007, there were a number of research projects that were trying to find safe subsets of JavaScript. There was FBJS at Facebook, there was Web Sandbox at Microsoft, there was the Kaha project at Google, my own AdSafe project, and others. And one of the hard problems we all had to solve was what to do about this. If you have a function and you call it as a function, this will be bound to the object of interest, and that's exactly what you want. That's a good thing. But if you call that same function as a function, this will be bound to the global object, which is a security compromise. And we have to prevent that. So how do you stop that from happening? And the approach that all the other projects took was to have translators. So they'd have a program that would read your program and spit out a different JavaScript program that had lots of indirection and runtime checking built into it to prevent this from being bound to the global object. And they all had the result of making the code much bigger, much slower, much harder to debug. So I took a different approach. I said, let's just make this illegal. If we see this in a program, we will reject it, and we're done. That's much easier. And my assumption was that if you take this out of JavaScript, you're still left with a functional programming language. It's still Turing complete, so you should be able to do everything that you need to do. So to test that hypothesis, I started writing in that dialect of JavaScript, and I was really surprised to discover that it wasn't harder. It was actually easier. It was easier to write programs. My programs were smaller and better. So I thought, that's pretty neat. So I don't use this anymore. And I stopped using null. So JavaScript has two bottom values, null and undefined. There's an argument in language design, should you even have a bottom value, but there's nobody who thinks you should have two of them. And JavaScript has two. And some people use them interchangeably, but they are not interchangeable. They behave differently in certain circumstances. So I decided I need to get rid of one of them, and the one I decided to get rid of was null. I stopped using falsiness. I decided that the falsy idea, the bullish value in JavaScript, was a bad idea. It was intended to reproduce something that was in C. In C is an undertyped language. So C will use the same value to represent 0, false, null, end of string, and a few other things. And so all the condition of an if is concerned with is, are you 0 or not? And Brendan wanted to have the same kind of idioms in his if statements in JavaScript. And I think that was a mistake. So I stopped using falsiness. I now want to have everything try to resolve to a Boolean, as Java did. I think Java got that right. I don't use for loops anymore, because in ES5 we got these wonderful new array methods, which will iterate over arrays, so there's no need really for fors anymore. I don't use for in because I managed to get object.keys into ES5, so that now gives you a nice array of all the innumerable own properties of an object. And then I can use the nice array methods on those. ES6 will have proper tail calls, and at that point I will stop using loops entirely. So here are two versions of the repeat statement. The one up there is using a while loop. The one down here is using tail recursion. So ES6 requires that when the last thing a function does is return the result of calling another function, instead of generating a call return sequence, it will generate a jump. And so that means that these two functions should run at the same speed with the same memory pressure. That because this is jumping back to the top of the function, it's reusing its current activation object, so it doesn't have to generate more stuff. We're not going to see any stack overflows. This can run as deep as we want without any performance penalty, which is great. So for a long time, we've had a performance argument for why you shouldn't use tail recursion. That goes away. So I'm really pleased about that. One of the benefits of this is that it enables continuation passing style and also gives us a form of goto which is safe. So the designers of transpilers have been asking for a goto because they have languages which might want to have a different set of control structures or flows than what you can get in the standard JavaScript set. And so they wanted to be able to emit their own goto so that they could have control over that. And we didn't want to do that because we knew what would happen if we put goto back into the language. So instead we have tail recursion, or proper tail calls, which are much better structured, higher discipline. Basically, it's goto with an argument list. Really good stuff. So I've been thinking a lot about the next language, about the language that replaces JavaScript. I feel that there's got to be a next language, because if it turns out JavaScript is the last language, that would be really sad. I mean, the children, right? You don't want to leave JavaScript to your children. Mama, Papa, what happened? How would you explain that? So there's got to be a next language. And I've been trying to identify it. What are the signs? What are its properties? How will we know when it is here? The only thing I'm certain of is that when the new language does appear, we will reject it out of hand, because we are as irrational and emotional as normal people. Now, this may sound like an insult, but I believe it is true. So here's my evidence. So it took a generation to agree that high-level programming languages were a good idea. The first generation of programmers were all writing machine language, which is really, really difficult. And then Fortran and the other first generation of high-level languages occur. And these languages made programming so much easier. And the programmers of the day mostly rejected them, because we cannot afford to give up this level of control. We need to be able to get down to the metal in order to do our work. We can't afford the potential loss of performance that we might get. It took a generation to agree that goto was a bad idea. Dijkstra publishes his letter in the CACM, and that starts a really vicious emotional argument that goes on for 2 decades. And then they're fighting and fighting and fighting, and the two sides can't really hear each other, and it's just noisy, and it just goes on and on. It took a generation to agree that objects were a good idea. Classes first occur in Simula in Norway. Really, really important discovery, which nobody takes any notice of except one grad student at the University of Utah, who thinks that this idea could be so powerful we could use it in a programming language that children could use to program their own personal computers, which is a really amazing idea to have in the late 60s. That leads to a cycle of experimentation, which leads to Smalltalk, which inspires C++ and pretty much everything that came after. And so the industry had to choose what its dominant object-oriented language was going to be. Was it going to be Smalltalk, which was the best designed programming language in history? Or was it going to be C++? And the industry, as you know, went with C++ because it had the advantage that you did not need to understand what object-oriented programming was in order to use it. And that decision was made by people who didn't understand what object-oriented programming was. C++ got some things fundamentally wrong, but every language since then has copied those mistakes. And it took a generation to agree that lambdas were a good idea. Lambdas as functions with lexical closure, with static scoping, were discovered in the scheme language, and it took 2 generations for that idea to finally get to the mainstream. Anybody know what language it was that brought that idea to the mainstream? Any guesses? Because we see it all over the place now, because it actually solves a lot of problems that we're now experiencing. The language was JavaScript. JavaScript was the first language to do that. So the reason these things take a generation is because we don't change minds. We have to wait for a generation of programmers to retire or die before we can get critical mass on the next good idea. Now, I was there when this happened with goto. There's this argument that was going on and on. You can't take my goto away from me. Goto is how I express myself. I'm a goto guy. There's all this performance that we get from goto. I'm an artist. Look at my goto art. And it just went on and on and on. You can't take it away from me. I need it to do my work. It's an essential tool. And predictions of all the terrible failures and all the problems that were going to happen if they took the go-to away. My cold, dead hands. And then one day it was quiet. It's like, are they gone? Can we get rid of the go-to now? Yeah, we got rid of the go-to, and everything's great. All the predictions about all the terrible things that were going to happen didn't happen. It turns out that getting rid of go-to made it easier to write programs with greater complexity. With go-to, complexity can easily get out of control and you get spaghetti code. And by going to structured programming, we could get more complex before being overwhelmed by the complexity. So who benefits from that? The people who are arguing against it. And that's the way it is with all of these paradigm shifts. Each of these is a paradigm shift, and it's really hard to get to the next one. And I believe that the next language will represent another paradigm shift, and that's why we will reject it. So I would sort all languages into two categories. I think they should either be systems languages or application languages. The dominant system language is still C, which I think is a problem because C has been around since the 70s. We know that there were mistakes made in C. We've learned a lot since then, but we haven't replaced it yet. I think that's really a problem. We seem to have lost the ability to innovate in system languages. But I'm more concerned with application languages because that's where most of us live. There's some languages that I think make the mistake of not knowing which side of the line they want to be on. I think the biggest design mistake in Java was that it was trying to be both. And as a result of that confusion, threads are required in application programs, which was a huge mistake. I think that was inexcusable. So I would take application languages and I'd split them into two categories. Those that do classical inheritance, which is almost everything, and those that do prototypal inheritance, which is pretty much just JavaScript. And for a long time, I was an advocate of prototypal inheritance, but I'm not so much anymore. So prototypal inheritance definitely has advantages over the classical model. When you're doing classical programming, you have to design your objects and then make them into classes. You have to decide, that's going to be one of those and that's going to be one of those. That's not too hard, but then you have to come up with your taxonomy. The taxonomy is where you decide how they are all related to each other. What's going to inherit from what? What's going to implement what? What's going to interface what? And it turns out that is really hard. It's really, really complicated, and you're doing it at the point of the project at the beginning when you have the least understanding of how it's going to work. And so inevitably, you get it wrong. You just get it wrong because you don't know yet what the correct solution is. And as you work, you start noticing how it's wrong, that things don't compose the way you want them to compose, that you start wishing that you had multiple inheritance because you just can't get these things to fit right. And as you start layering more and more classes on top of it, you find that that breakage is seeping up into all of the levels. And eventually it may get so bad that you decide we need to refactor, which is really scary because that means you're going to tear all the code apart, and you don't want to do that because it might not ever come back together again. And in the prototypal model, that doesn't happen. I tell this story to people who do the classical stuff, and they go, wow, that's really interesting. Except you're still going to have to refactor sometime, right? I go, no, you don't have to do that. I go, wow. But you're still going to refactor, right? I mean, just, no. So the principal advantage we get from the prototypal model versus something that just copies functions from one object to another is memory conservation. That using object.create instead of object.assign, the value we get is memory conservation, which is something that made sense in 1995. But since then, Moore's law has been so incredibly generous on memory capacity that that's not a reasonable trade-off anymore. You now have literally gigabytes of RAM in your pocket right now. You just cannot imagine how much memory you're walking around with. So trying to shave bits off of an object, it's in the noise. It doesn't matter anymore. When's the last time you saw a browser given out of memory error? It just doesn't happen. There are now two kinds of properties. There are own properties and inherited properties, which sometimes work exactly the same, but sometimes work differently. Whenever you have things which are almost the same but different, that's a source of confusion, and confusion leads to bugs. We get retroactive heredity. So what an object inherits can change after it's constructed, which I've not found any good uses for that, but I've seen very bad uses of that. One of them is that it is performance inhibiting. So modern JavaScript engines go very fast by making assumptions about the shapes of objects, but they have to be pessimistic about prototype chains because they cannot see when the things in the chain are being modified. So I'm no longer an advocate of prototypal inheritance. I'm now an advocate of class-free object-oriented programming. I think class-free object-oriented programming is JavaScript's gift to humanity. So here's how I think it should work. So we'll start with the idea of block scope. I assume that everybody's familiar with block scope. We've got two blocks. In each block we can create variables, but the variables are only visible in the inner blocks. They're not visible to the outer blocks. But the inner block can see the variables of the outer blocks. And we can do the same thing with functions, because a function is just a block with some extra plumbing around it, which allows it to be executed in the future. And so we've got the same relationship, and we can express that relationship as a Venn diagram. So this is the set of the variables that the outer function can see, and this is the set of variables that the inner function can see. And we can see that the inner function encloses the set of the outer function. And that's why we call this closure. I think it's unfortunate that we call it closure because, at least in English, closure is very overloaded. Some people think it means retribution or vengeance. And we're just saying one set closes over the other set. So it took a long time for this idea to get to the mainstream because of this case. That suppose the inner function survives the execution of the outer function, which would happen if we return it. So the inner function wants to have access to A. So when the green function is called, A is put onto the stack. It returns the yellow function. And then we'll call the yellow function. The yellow function wants to go to A, but A is no longer on the stack, so boom. And it took us like 40 years to figure out how to fix this. And it turns out the solution is trivial, that you don't allocate on a stack, you allocate on a heap, and you let the garbage collector just clean it all up. And this is what JavaScript figured out, and now all of the languages are trying to do this, even Java. And this is such a powerful pattern that having a function that returns a function, higher order functions, there is so much power, so much expressive power in this. This is how we should be writing programs. So this is how I recommend making objects in a class-free way. So I've got a constructor function. I recommend passing in a specification object. You could still pass in individual parameters if you want to, but I think this is a more powerful way to do it. Because you can just put an object literal inside the call to the constructor, and that essentially lets you have named properties. So you can have the properties in any order. Some years ago, I wrote a constructor that had 10 arguments in it, which was a problem because nobody could remember what order they went in. And after a while, we discovered that nobody used the third argument, but we couldn't take it out because that would have broken all the code. So if I'd been smart, I would have just passed in an object, and then missing arguments, we could fill in reasonable defaults. Extra arguments, we could just ignore. And again, the order wouldn't matter. So I would use that to create my member variables. This, again, is using the destructuring syntax. So I can name as many member variables as I want and initialize them with properties of the object that have the same value. Then if I need to, I can call other constructors, passing in the same specification object, because we'll be using the union of all of the specifications. That's what the user will pass in. And they'll make something and pass it back, and we will extract from it just the methods that we need. This is a solution to the banana problem. Have you heard about the banana problem? You want to inherit a banana, but you end up also inheriting the gorilla who's holding the banana and all of the rest of the jungle. You just wanted the banana. Well, now you can say banana, and you'll just get the banana. And because we're copying the methods out, you can call as many of these as you want. So we can have a compositional form where we'll call other things and get all of the stuff that will make our object better and just incorporate it into our own local variables. Then we'll create our own methods, and because of closure, our own methods will have access to all of that goodness without using this. And then we will have an outgoing object where we'll simply list the new public methods, and we'll freeze the object. So now the object will be immutable, incorruptible, inconfusable, an object of high integrity that we can use to build secure, reliable systems. So when we started doing object-oriented programming, it sort of starts with Pascal records, where we've got a simple data type with named fields in it, and we have a name which gets us to a value. And we extend that idea by saying the names can also represent methods or functions that will act on those values. And that was an important step forward, but it should not have been the last step, because it leads to a style of programming where you're focused on the individual properties and not on the whole. And so it's hard for the whole to have integrity when you allow access to the individual members. So what I recommend instead is that we raise the level of the interface more in terms of actions and less in terms of the specific data items, so that there'll now be two distinct types of objects. There will be objects containing just data, which will be collections of values which we can pass around as parameters to objects. And there'll be objects that contain only methods which will act on those objects. The mutable data will be held in variables in the constructor function. And I think that's how we should be writing stuff. So I need to confess, I made a bug in 2001, and it's really been bothering me, and I need to tell you about it. So I wrote a JSON parser in Java to show how easy it was to write JSON parsers, and it included this declaration of a variable called index that was an int. And that was intended to count the number of character positions you were into a string or a stream. In case there was a syntax error, then it could report at what position the error occurred. And int is pretty big. That'll get you to about 2 billion. And at the time, I'd never made a JSON object that was bigger than a couple of K, so I thought, this is future-proof. This is going to work fine. Until a few years ago, I got a bug report from someone who found, or who was trying to parse a JSON text that was several gigabytes in size. And there was a syntax error passed too. And they got a wildly wrong error message that was negative. But they were very smart, and they very quickly recognized what I got wrong. And it was because of this int thing. I hate ints. I think ints are one of the worst things we've done to ourselves in programming. And the problem with them is overflow. What happens if an int overflows? They do the worst possible thing. You throw away all the most important significance, and there's no report. And so it's really hard to have integrity in your application if you have a number system that can go wildly wrong without notification. So why did this happen? It's because it made sense in the 50s. In the 50s, we were making computers out of vacuum tubes. Vacuum tubes are big and they're hot. They draw a lot of power. They burn out really quickly. And so if you can figure out a way to reduce the number of tubes in your design, then that's really good. And some genius, and I believe he was a genius, figured out that if we use complement arithmetic, then we don't need to build a subtract circuit. We just complement before add and ignore the overflow. And that was so much easier. And we're still doing that. It's not the 50s anymore, but that's how our systems still work. Also, memory used to be really expensive and scarce. I don't know if anyone remembers the Atari 2600 VCS. That machine had 128 bytes of RAM in it. 128 bytes. So the guys who programmed that machine were heroes. They had to figure out how to make a video game work in 128 bytes, and so they would want to use memory really, really carefully. But today you've got gigabytes in your pocket. It's a different world. So when you're programming in Java, every time you create a new variable or property or parameter, you have to ask byte, char, short, int, long, float, or double. Which one? You have to pick one of those. And if you get it right, then the program will work. And if you get it wrong, the program is eventually going to fail, but it will probably not fail in your tests because your tests assume that the types are right. But your type is wrong, and tests don't find those sorts of type errors. You expect the compiler to find them, but the compiler is not finding it. And there's no benefit from choosing the right one. The reason Java gave you all those choices was, again, because a long time ago there wasn't much memory. But trying to shave bits off of a variable now is a complete waste of time. JavaScript, on the other hand, has only one number type. That means you don't waste any time trying to decide what the type of a number is, and you cannot make a mistake by choosing the wrong number type, which is good. In that way, JavaScript is strictly superior to Java and most of the other languages. The only problem is it's the wrong type. And the reason it's the wrong type is because of this. There are some people who think this is okay. I think this is not okay. JavaScript's problem is it's using the IEEE 754 floating point standard, which is a binary floating point standard which cannot accurately represent the decimal fractions, which is only a problem if you're on a planet that uses a decimal system. But we are, and so it doesn't work. So it's binary floating point. So why are we using binary floating point? Because it made sense in the 50s again. So in the 40s, when the first von Neumann machines start coming online, they're integer-only machines, but they were built and used by mathematicians who want to be doing math on the real numbers. So they start by doing scaled arithmetic, which is really difficult, and someone figures out we can do floating point. We can represent a number as two numbers. One is the collection of digits, and the other is where the decimal point is. And they could have libraries which would let you add and subtract and multiply and divide using that representation, which made programming much easier and much more accurate, but it was really slow. So when machines start to become mass-produced, there's interest in putting that into hardware. But the problem is, in decimal floating point, in order to adjust numbers, you have to be able to divide by 10. And dividing by 10 with vacuum tubes is really hard. So some genius thought if we change the basis from 10 to 2, we only have to do a shift, and we can do shifts for free. So it was like, brilliant, we'll do that. And we're still doing it. Now, the business programmers at the time said, we cannot use that. You cannot represent money. And we have to add up the money correctly or people go to jail. So we're not going to do that. So they came up with their own system called BCD, binary coded decimal. So when you ordered your mainframe, you would either get the floating point package and run Fortran, or you get the BCD package and run COBOL. And so it was sort of two worlds. But then computing kind of grew up and swallowed everything. COBOL disappeared, and Java became the successor to COBOL. But Java is a child of Fortran and not COBOL, so it gets the numbers wrong. And everybody's been getting the numbers wrong ever since. So I propose to fix it. And my solution is called DEX64, where I have a 64-bit quantity which represents numbers. And it's very much like the representation that was used in the 40s. The coefficient is a 56-bit number, which can contain 16.3 digits approximately, and the exponent is 8 bits, so that gets us over 100 in either direction, which I think is enough for most applications. And the value of a number is simply the coefficient times 10 to the exponent. So that's all of the encoding. It's really simple. So you can take any existing int, shift it 8 bits, it's now a DEX64. In a hardware implementation, numbers with the same exponent, which would include all of the integers. Every integer will have an exponent of 0. They will add in one cycle, which will completely eliminate the need for ints, because ints will no longer give a performance advantage over floating point. These will do those numbers very, very fast. And because it's a decimal representation, it can exactly represent all of the numbers that are important to humanity, which is something a binary floating point cannot do. There's a software implementation of it available for the X64 or AMD 64 series. My hope for this is that this will be the one number type in all future application languages. Now, it may seem an audacious thing to say, I'm going to try to convince everybody in the world to change their number types. But it turns out I don't have to convince everybody in the world. I only have to convince one person. And that's the man or the woman who designs the next language. If I can convince that genius that they want to make a language which represents numbers the same way that humans think about numbers in order to reduce confusion so that we can make fewer mistakes, then this is the way to go. Now, it turns out I have some experience at convincing everybody in the world to do the right thing. For example, there's the JSON data interchange format. This is Google Trends showing XML versus JSON. And you can see that the world has steadily been losing interest in XML since 2004. And JSON's been very, very quietly creeping up. Again, there's no JSON industry. Nobody's making money on JSON except for the people who are using JSON. And Google shows that finally JSON becomes more interesting than XML. This is a more recent snapshot. You can see that it's going, and today's snapshot, JSON's just up there, and you did that. And the reason this happened was there was no paradigm shift necessary, because in 2005, when suddenly the web became interesting again, there were a lot of people who came in to the web to start using JavaScript, and they were told you have to use XML. And you very quickly decided that's too hard. Let's use this other thing instead. And so we didn't have to wait for a generation to die because a new generation came into the market. So I didn't intend for JSON to be the last data interchange format. It's really good for the thing that it was designed to do, which was to allow programs written in different languages to communicate data back and forth. And it does that really well. But it's being used for other things, and for some of those applications, it's not ideal. So it may be that other data formats should be invented. So if anyone here is thinking of creating one of those, let me give you some advice. First is, please don't break JSON. The best thing I did in JSON is not perfect, but the best thing I did was I did not put a version number on it. So there is no way of changing it without breaking it. So please don't try to break it. Don't try to amend the JSON standard to add some new stuff. Make a new standard and make it better. I recommend don't just make it better, make it significantly better. Don't just be JSON with one little thing on it. Because if you have something which is JSON-like but not quite JSON, then you're adding a confusion tax, which can turn into errors and be a problem for people. So if you're going to do that, add enough value to it to justify that cost. And please give it a better name. Because the worst thing about JSON for sure is the name. For one thing, nobody knows how to pronounce it. I say JSON, most people say JSON. It turns out the correct pronunciation is JSON. Everybody? I've seen people take JSON and put a letter in front of it or a letter behind it or a number or something. Don't do that. Give it a completely different name because the name's not good. So it stands for JavaScript Object Notation, which means, that name itself is confusing. So having JavaScript in there, well, there's already confusion about what is JavaScript. And is it Java? Is it what? And then having JavaScript in the name, it suggests that the JavaScript standard is what defines what JSON is, or it only works with JavaScript, and none of that's true. There's a JSON standard, which is what JSON is. So I put the word JavaScript in there to give recognition to JavaScript, because it existed in nature. I didn't invent JSON. I just identified it as already a feature of JavaScript and suggested it could be used independently. And so I was trying to give JavaScript credit, but it wasn't like I was trying to get on JavaScript's coattails, because at the time JavaScript was the most hated language in the world. So, yeah, we're part of that. That wasn't getting us much love. Then the idea of object here is JavaScript's idea of object, which I think is a good one, of a collection of properties, of a casual thing. Whereas in most of the other languages, that's not what an object is. An object is an instance of a class, and it's a very rigid thing. So people in those languages get confused. Why are they calling this thing an object? Notation is okay. I can't find any problems with the word notation. So if you want to use that, that's fine. So finally, I want to talk about responsibility. And this is my personal view. Who am I responsible to when I'm writing a program? My number one responsibility is to the people, to the poor bastards who are going to have to use my software. I want it to be really good for them. I don't want it to error out. I don't want it to fail. I don't want it to be slow. I don't want to frustrate them. I don't want to damage their lives. I don't want to hurt them in any way. I want them to benefit for using my software. I want it to be good. Now, I've seen programming teams who hate their users, who think those people are stupid, they're the source of all our misery, they don't understand how to use our stuff, they ask for new features that don't make any sense, they do not appreciate our genius, we hate them. That is a terrible attitude. It's completely toxic, unacceptable. We should never, ever, ever do that. Everything we do should be in service to humanity. We have this idea in our profession that we are making the world a better place, ignoring all of the evidence that shows that we're not. But I want to at least make it better for the people who are using my software when they are using my software. Then number two is the team. I want to write good stuff for the team so that someone else on my team can take my code and make it better. I don't want to be putting traps or hazards or confusions into my code which are likely to make my team members fail, including team members who we haven't hired yet, who I haven't met yet, including future me. That future me may not remember why I did the things that I did and struggle to maintain my own code. Our software has gotten so complex that it's now a team effort. That it used to be one person could write an operating system. I don't think that's likely to ever happen again. So we have teams building stuff, and it's similar to team literature. If you have a team that's writing a magazine or writing an encyclopedia, you would like to have everybody on that writing team write with the same voice. So to a reader, it looks like this was written by one writer. And that in no way restricts the creativity of the writers, because the important thing is not how you use your punctuation, but how clearly you express your ideas. And having a house style does not restrict that in any way. That's the way you display genius. So on my team, I want everybody on the team to be writing in the style of the best, most professional programmer who ever lived. I want everybody to be writing at that level. I don't want anybody dumbing down the code because they need to express themselves. Then number three, management. If management asks for it and it makes sense, okay, we'll do that too. Now some managers will go, whoa, wait a minute. We're supposed to be in charge here. Shouldn't we be number one? And I think, no, I think I got this right. So one of the most important jobs of a CEO or a president is to focus the company on the outside. There's a tendency, particularly in large companies, everything becomes inward focused. We're all about our own process, competition for our own resources, and the CEO kind of turns everybody around and will say things like, be the customer, be a customer champion. Everybody is doing customer service. They're turning people outward. We need to be aware and serving the people on the outside because that's what we're all about. And so, that's the people. And number two, there's a tendency in companies that the software is not an asset. It becomes a liability, that there's so much crap and clutter in the code that it is the reason why we can't compete effectively in the marketplace. We've got a new idea that we could implement in software, but it means we have to get the old stuff to work, and it's just really, really hard. It slows everything down. But if we wrote everything for the team at that level of quality, then the software is not a liability. It is an asset, and we can go to market much faster. So before we go, I just want to leave you with one piece of advice, and I'm really serious about this. Please do not make bugs. Thank you.
No, come on. I mean, do it properly. This gentleman here is the discoverer of JSON.
Please sit down.
Thank you very much, Douglas. Would you be happy to take a question or two?
Please.
Why do you think the other JS alternatives haven't succeeded like Dart?
The problem with Dart and all of the other would-be next languages so far is that they're not the next language, that they are re-implementations of the previous language. So I think the next language is going to represent a new paradigm. It's not going to be going backwards, it's going to be forward. So it's going to be doing things that we're not familiar with yet. I think most likely it's going to be concerned with distributed programming. Because from the beginning of programming, it's always been sequential stuff within one machine. And that's not how the world works anymore. It's now distributed machines. We've got lots and lots of machines. We've got clouds now. We've got lots of stuff. So I think the next language wants to be much better at distributed programming. So I think it wants to not be about classes. I think it wants to be about messages. So a message-oriented language in which you're just firing messages, not necessarily waiting for returns, but having mechanisms for dealing with the consequences of that. I think that will probably be the next language. So it'll probably be actor-based, or if not actors, another similar idea, but something that's really, really good at handling distribution.
We've got no more questions from online, but we've got one from the room.
Yes, you mentioned during your presentation that you prefer to use array for each and object keys. What about the cases when you have to remove the key from the object, or when you have to remove an element from an array?
I never do that. I can't think of any time when I've had to do that. I'm always building stuff. So instead of trying to mutate something, I will make maybe a new thing which is the same as the old one, but not having that. But I can't think of cases where I'm actually trying to remove stuff.
Like remove, I don't know, you have a cache dictionary and you want to remove some entries after a certain amount of time, and then you remove elements you from your structure.
Yeah, I think instead I would want to use a weak map, and just put stuff in the weak map and then let the garbage collector clean it up.
Okay. Thanks.
You mentioned numbers, and that you strive to get just one number type, which would be also able to represent floats. So what would your recommendation be for places where only integers are allowed, and we are trying to pass a float, like, for example, indexing an array? So do you recommend like throwing an exception? Should the language throw an exception, or should there be some standard rounding up or down? Do you recommend anything? Or
I think it probably wants to be an exception. So with Dex64, that's a pretty easy thing to do. You look to see if the exponent is 0, and if it's not, then you would reject. JavaScript, I'm not sure what JavaScript will do is it'll try to turn that floating point number into a string. And so, if you try to go to 1.0, you'll get quote 1.0, which I think is weird. So I think arrays should not behave that way, but that would be for the next language. Thank you.
We've got one more question over here. I think it's going to be the last one, as Douglas now needs to move to the next room.
Do you think that unit testing is important in JavaScript? Like, is it in your toolbox?
I do unit testing, but I think unit testing is overrated because most of the errors happen not in the units, it's in the connection between the units. And so I'm more interested in sort of system testing. Because I've seen unit testing frameworks where you've got all of these mocks and props and stuff, and it turns out all that you're really testing are the mocks and the props and the stubs and everything. So I have a test system that I wrote called JS Check, in which I can write a proposition about what my system would be doing if it's correct, that I can write as a function, and it will then generate random values that it will throw at that function and try to disprove my assertion that my system is working correctly. And I find that to be much more reliable than unit tests.
This was the better parts, and I think this is the moment where we really energetically thank Douglas Crockford for his talk. Thank you, Douglas.
Thank you.